Okay, I'm so pumped. I'm going to tell you why mathematics is so amazing. So my friend has been making relativity theory videos on YouTube. If you want to find them, you just search for Imagine Physics. His name is Anssi. Here's his YouTube channel, is Imagining Physics. His name is Anssi. With those things, you can find him on YouTube. This is his channel. And so, as you all know, or some of you don't, that when you travel, or if you could travel with almost the speed of light is like 300,000 kilometers per second. Now, if you would go 200,000 kilometers per second, then weird things are going to happen. Like Albert Einstein famously predicted and calculated and theorized that things will shrink and time will flow slower in those who travel fast, and those who travel slow, their time is going to be fast, and etc, etc, etc. I mean, this whole theory about that with square roots and stuff, and everybody knows the famous formula E equals mc squared, which does not have a square root in it. But so I'm completely missing the point. So okay, so what I wanted to say is that Anssi has been making videos where you're traveling in a virtual city, and you can see how the world bends in weird ways when you travel in this weird city. Let me show you some other footage from here, something like this. Okay, just go to his channel to see more. Look, this looks amazing. Now here in this video, I'm gonna pause it. I'm sorry. Here. What's happening is that we are going towards a flat surface. We're going towards a flat surface. I'm sure you want to. Okay. No. Okay. Yeah. But we'll see it as a circle because we see the light waves that are coming behind us as if they were in front of us, or like from the sides of us as if they were in front of us. And this is part of the relativity theoretic effects that Anssi is visualizing. Now, we wanted because we want to make a planetarium movie out of this, a full dome movie out of this. And we were thinking that we would fly drones in a real city and film, the 3D image of a city, and then we would be able to incorporate these relativistic effects and see what it looks like to fly, let's say, in our city, Helsinki, or in New York, or wherever, as if it was like with speed of light, so you could see how things bend and stuff. Now, actually, Anssi already made a video where we are flying in Helsinki with almost the speed of light, and we can see the color shifts, the bending. If I scroll a little bit further, you can see our main cathedral bend. It's pretty amazing. This is what it would look like if you could go almost the speed of... I mean, technically speaking, if speed of light was less, if it was like 100 kilometers per hour, then this would look like this. Because if we go almost at light speed, then this video would last for like a split of a second, like that. That would be the length of this video if we went actually with light speed. Okay, now problem we ran into was that in order to do this video, this one that you saw, is made from a 3D model of Helsinki, which is why it's a very low quality. I don't know if you can see it here, but for example, now there is no sea. So this is some gray stuff over there. Why? Because the 3D model just ends there. It's low resolution, and if we go and look carefully at this cathedral, we will see that it's actually screwed up. I mean, look at that. This is not the real cathedral. Over here, it looks very weird because it was made from satellite photos by integrating them with some algorithm. Now, we had a problem that if you want to make a real good quality version of this, you would have to create a 3D model of Helsinki because, or any other city, because in order to calculate how things bend, you need to know how the light travels into your eye from them. And we thought that you have to know the distance of every single pixel from your eye. This is how Anssi used to calculate these things. And then recently Anssi came up with a formula which says that according to relativity theory, and this is by the way not true in standard Newtonian physics, but in relativity theory you can calculate all these things without knowing their distance from your eye. It's enough to know their direction coming, which was the direction they're coming into your eye from. So now we realize that we can just use a 3D 360 camera, you know, those cameras which are used for VR and stuff, where you just film everything that is coming into the camera from all angles, and that's enough. Why? Because Anssi was able to prove mathematically that in relativity theory you can actually, you know, you can derive, I'm not going to show you the equations now because I'm not even aware of them, but like you can derive that the distance from your eye to the object will cancel out somewhere. I believe this is not a trivial thing to prove because my understanding is that it's not true if physics was classical, like Newtonian or Galilean. So you have to really understand relativity theory mathematics, which is, you know, as far as I'm concerned, not so easy. And then you can deduce this thing. And once you deduce it, we realize that it's much cheaper to make those videos that we wanted to make. So we're saving a lot of money, we're saving a lot of time because of one mathematical formula. And this is why I'm so pumped, because this is exactly what I want to say, is that mathematics can, with a single formula, with a single equation, with a single theorem, simplify our lives. It can like make everything much easier and faster and save money and save time, and all is based on how we understand the world around us. This has nothing to do with IB mathematics, really, but I still post it on this channel because I can.